Okay, so today we'll try to understand area under the curve. Consider you have a function and let's call it y, which is equals to fx. And the area under this curve, even that is a function of x, because that area can vary depending on from where you start and where do you end it. So what if I say that I take a very small portion of this area? Because area is a function of x again, so is the curve itself. So let me call this small portion of area delta A. And what will that be equal to? That is the area between a value x and another value of the variable x, which is x plus delta x. So I can say that my area, which is delta A, is equal to the area to the left of this line minus the area to the left of the line where x as a value x. So coming out of this very small area, to understand this thing, this area is a very small area. This very small area is basically equal to the value of y multiplied by the very small change in x, which is delta x. That will give me this very small area, which is delta A. Is this clear?
You have to only give a portion because
Yes,
of
you're
the
right.
curve.
That will be a very small portion. Consider it almost as a straight line. Here it's quite zoomed in, so that might look like a big portion to you here. But think of it as a very small, very thin line that you have. The area of a very small line. Now, does that make sense?
Yes, it will be close to 0 point something.
Yes, something very 0.000. So a small change in x on x and a very small value of y, because y is hardly changing. If you draw a very thin line with a pencil, will your y change on that line if you go from left to right?
So not significantly.
Very good, not significantly. So I can say that y will be equal to the small change in a over small change in x, or I can say that area will be equal to small change in x multiplied by y. I can approximate my area to that, can't I? So try to understand this now. When I say that the small change in A over small change in A can be approximated to dA by dx, where dA is the change in area and dx is the change in x. Can I say that?
Yes, so you're just differentiating it.
Yes, and I'm just putting it into a perspective of variables, right? With small changes.
Yes.
We know that these are numerical small changes. अपने दिमाग में रखने के लिए we say 0.0001, 0.0002, 0.0003 in our mind. But the small or the calling it negligible is just a relevant term. So why not give it and why not bring it into some terms of variables and call it dA by dx? Can we do that?
Yes, sir, we can.
Okay, now it's a very easy thing to understand. The derivative of the area is y. How do I get the area then? Can I get the area if I integrate this entire thing?
Yes, sir. Divide. Yes,
The
multiply
derivative of the
of
area is y. So can I get the area when I integrate y?
Yes, sir.
That's exactly what is written here. So technically we get the area function when we integrate the curve with respect. If I'm saying integrating y with respect to x, if I integrate y with respect to x, I get the area function. Is this clear?
Yes, sir.
Now, when I apply limits to that function, I'll say I need the area from this part to this part, the area in between those things. So I'll get the area B से अगर मैं लूं, तो B से लेके पीछे पूरा infinity तक area, I'll get that.
Yes, sir, you will.
And then if I subtract A से लेके पीछे पूरा infinity तक का area, so will I get the area in between these two lines?
Yes, sir.
So that is what the definite integrals are used for. I'll say that if I integrate the function fx, whichever is the function of the curve, and apply the upper limit and the lower limit, which are obviously the values of x, I'll get the area in between those two parts. And the area is between the curve and the x-axis, and this area has to be above the x-axis, because when we go below the x-axis, it will be an entirely different scenario. Some things will change. So right now we are specifically talking about the part when we are above the x-axis. Is this clear?
Yes, sir.
So this is the primary purpose or application of the definite integrals. Similarly, the example in the book says that if I were to find the area between 3 to 2, can you attempt this one on your own? Okay, what if, for example, you were to do the same thing in this one? Now you are going for the area which is below the x-axis. Once you try to attempt it, you'll get a negative value. Now there are two ways to understand this thing. We will say that for area, we'll do it two ways. Below, if you are trying to find the area below the x-axis, there are two things that we can do. We can either, because we already know that we'll get a negative area. Why? Because the higher value will yield me a higher value, and the lower one will give me a lesser area, and then I'll get a negative value. So there are two things when we have to do area below the x-axis. We will say,
Can change the limits to negative.
no, we will not change the limits to negative. One thing is, we either multiply the entire area with a negative value, knowing that we'll get a negative answer, so we already prepare for it. So we'll say if we were to find area below the x-axis, that is one thing that we can do. We already know b being the upper limit, a being the lower limit. We apply the negative sign beforehand so that we know what we are doing, and we'll eventually get a positive area. Is this clear?
Yes, sir. So why
Another,
don't we multiply the limits by -1?
yes, we do not multiply the limits by -1. That will be an entirely big, because that is only possible when we have symmetrical curves, and that too vertically symmetrical, and that will not always be the case.
Okay, sir.
Another thing that we can do is we can just switch the limits, because we know once we integrate, we apply the upper limit and then we subtract the lower limit from it. We want to reverse the operations eventually, right? We can take the lower limit, the lower value, and make it the upper limit, and the higher value and make it the lower limit. Is this clear?
Yes, sir.
Or another thing that we can do, we find the entire area and we just use the mod sign. Knowing the fact that we'll be yielding a negative area, we can do either of these three things and all of them will give us the same answer.
Yes, sir.
Make sense?
Yes, sir.
So one thing that we have learned from this is whenever we encounter a definite integral, for example, if you were to do this definite integration and you do it this way, you switch the limits and you multiply it with a negative sign, you again get the same value. Make sense?
Yes, sir.
Sure. Because see, what will you get on the other hand? If I'm writing the function x, I'll get fb minus fa. Is that right? And here I'll get fa minus fb. So eventually I'll get the same thing on both ends. Is that right?
Yes, sir. That's right. So, but I think the mod one is easier.
See, all of these are absolutely fine. None of them is wrong. You must understand it and use whichever one you feel is right for you. Is this clear?
Yes, sir.
But this one thing we have learned here said that we can simply switch the values or the limits of any particular integral and multiply the entire integral with a negative sign, and we'll still get the same result. Make sense?
Yes, sir, it makes sense.
So this is one thing that we have learned through this exercise, that if we were to switch the limits of an integral and multiply the entire integral with the negative sign, it will not change. We are not technically changing the integral. Is this clear?
Yes, it's clear.
Now let's try to attempt a few questions from the exercise. We'll start with the basics. Okay, now this one. If I were to find the area, how will I find it? Once I integrate the curve, this is how we find the area. I'll just write it once, and we'll not always have to write it, but we need to understand it. I'll integrate y with respect to x and apply the limits 3 and 0 in this case. Is this right or wrong?
Yeah, right.
Now, I cannot integrate y with respect to x. I need something in terms of x. Is that right?
Yes, sir.
See, technically, when we are integrating, when we are
So first,
differentiating, when we say dy by dx, what are we technically doing? We say that the change in y divided by change in x, right?
yes, sir.
So differentiation is technically a division operator. Is that right?
Yes, sir.
I'm dividing the variable on the vertical axis with the one that is on the horizontal one. So integration should represent a multiplication operator. Is that right?
Yes, sir.
We'll do that in details when we go to application of integration, especially in kinematics as well. Just giving you a hint over here. Technically, जब हम integrate कर रहे हैं, the quantity on the vertical axis को अगर मैं integrate ही कर दूं, so I'm technically multiplying it with the quantity on the horizontal axis. Y is a variable; it can vary. Dx is considered a very small change in x. And when I multiply all of the lines, imagine I have many lines on this. And when I add all of them together, that is how I'm getting the entire area. Is this clear?
Yes, yes, it's clear.
Okay, so now y is x cubed minus 6x squared plus 9x. In add maths, you're not asked all these things in detail, into these concepts in details. But if you are aware of all these concepts, it's a very good thing for you, for all the future mathematics that you have to do. So for the first thing that we'll do here is we'll integrate x will get the power 4 upon 4 minus 6x cube upon 3 plus 9x square upon 2. We know when we are concerned with the different integrals, we do not write plus c because it will eventually be cancelled out, right?
Yes, sir.
3 to the power 4 upon 4 minus 2 into 3 cube plus 9 into 3 square. Simplify wherever you can to make it easier for yourself. And when we put 0, we get everything 0, and that will not be the case in every function. So be very careful when plugging in the value of 0. Can you tell me the area that you get? I've trusted you with this one. Okay, now in the second one, we'll again integrate y with respect to x to get the area between the curve and the x-axis. Upper limit is 9 and the lower limit is 0. I already know what y is. It is 3x to the power half minus x. So first we integrate, which is 3x to the power 3 upon 2 upon 3 upon 2 minus x square upon 2. Upper limit is 9, lower limit is 0. Always simplify if you can. 2x to the power 3 upon 2 minus x square upon 2. Upper limit is 9 and the lower limit is 0. Can you plug in the values and tell me the area? Again, in this one, we already know that we need to integrate the equation of curve, which in this case is 3x. Upper limit is 3, lower limit is 1. 3x plus 6x to the power -2 minus 5. So 3x square upon 2 plus 6x to the power -1 upon -1 minus 5x. The upper limit is 3, the lower limit is 1. So the area will be equal to 3 into 3 square upon 2 minus 6 upon 3 minus 5 into 3. Minus, when I plug in the lower limit, 1 square upon 2 minus 6 upon 1 minus 5 into 1. Is that right? So what is the area that you got?
Sir, 6.
6 unit square. I'm trusting you with the value. Okay, in this one, again, the equation of the curve is e to the power x plus 2, e to the power -x. The upper limit is 1 and the lower limit is 0. So let's integrate. How do we integrate exponents? The power remains as it is, and we divide by the derivative of the power. The derivative of x is just 1. Similarly, the power remains as it is, and we divide by the derivative of the power, which is -1. Upper limit is 1 and the lower limit is 0. Is that right?
Yes, sir.
So when you plug in the upper limit, e to the power 1 plus -2 over e, and when you plug in the lower limit, e to the power 0 is 1 minus 2 over e to the power 0. So area is e minus 2 upon e minus, and then this is 1 minus 2. So in order to keep it exact, this will be this. Is this clear?
Yes, sir.
Moving on to the next two parts. Let's give it a try. Okay, so one thing that you must really be careful with is when you are dealing with trigonometry, the angles must always be in. Yes, bache?
Radians.
Yes, so the integral of sine is negative cos, and the integral of cos is sine. Upper limit is pi upon 2. Lower limit is 0. And a 0 is not always a 0, especially in case of trigonometry and exponential, so be very careful with this. Once you plug in the upper limit to -2 cos of pi over 2 plus 3 sine pi over 2. Then -2 cos 0 plus 3 sine 0. So the area that you must get is 3 minus 2, 1. Is that right?
Then 5. I got 5.
How did you get 5? Okay, yes, this is -2. Absolutely right. You must get 5. Sorry, my bad. It's 5 units square. Okay, so in this one, again, trigonometry, and now you will understand the reason of using a radian, hopefully. Okay, so the function is 1 plus sine 2x. Now remember, radian is a measure that we have got from the ratio of two lengths. Is that right or not? Right?
Yes, sir.
So let's see, what do we get when we integrate this? We get x plus x minus cos 2x upon 2 and the upper limit is pi over 2 and the lower limit is pi over 4. Now, when I plug in these values, not only am I putting them in the cost function, but I'm also putting these values separately in place of x as well. Is that right?
Yes, sir.
Because they are already the ratios of length, they can easily be used here. On the other hand, trigonometry in degrees would not help us over here. Is this clear? So what is the area that you get?
Sir, 2 plus pi upon 4.
So 2 plus pi upon 4. So I'm trusting you with this one, and I've already told you the trick to do these questions.
Sir, if you write it that way, then
Which
it
way?
should be on 5 because 2 is also under 4.
Okay. So 2
Right.
plus pi upon 4. So you're telling me if I write them
0.
separately,
5.
half plus pi by 4.
Yes, sir.
Okay, that's fine. Good. So now what happens if we go below the x-axis? We have just figured that out, that we'll either use mod, switch the limits, or multiply the entire thing with a negative value. What do you want to do here? Mod?
Yes, sir.
That's perfectly fine. So write y as x square minus 2x, and I need to integrate it with respect to x. Upper limit is still 2, lower limit is 0, and I integrate and put the entire mod. So it is x cube upon 3 minus 2x square upon 2. Limits are 2 and 0. Which is 2 cube upon 3 minus 2 square minus 0 cube upon 3 minus 0 square. So the area is 8 upon 3 minus 4, 3 by 12. Minus 4 upon 3, which is 4 1 whole 1 over 3 units squared. Is that right?